So let's talk about characterization of DFA, right? So characterization of DFA says that when you are at any state, present state is Q, right? And if you are giving any input symbol, you must have to reach exactly one output state or the next state. Output state means the next state. It should not be more than one output state by giving only one input symbol. This is the first condition, right? Second condition is what? I'm just explaining all these conditions, then I will explain it with the help of state transition diagram, right? Next one is what? Mapping all the states with input symbol is compulsory. Say for example, I'm having Q as a Q0, Q1 and Q2. Suppose I'm having three states, right? And for this input symbol, suppose I'm having two input symbols, that is A and B. So what does it says in DFA? That mapping all the states with input symbols, that means Q0 must be mapped with A and B both. Similarly, Q1 also must be mapping with A and B compulsorily. Similarly, Q2 must have to map with A and B compulsorily. Now the question arises कि अगर ऐसा कोई possibility अगर होता है कि we are not mapping all the states, then what is going to be happen? For that thing, the third condition is given here. If a state is not defined on a mapping, then create the dead state, right? Then create the dead state. Okay, fine. So let us take an example, and on the basis of that example, I will try to explain you about whether that machine is in DFA or not. And if it is not in DFA, then automatically it will be in your NFA. Let's watch this example and try to find it out whether this machine is in DFA or not, right? So how it will be calculated, how it will be determined? I have already told you that characterization of any machine, whether it is NFA or DFA, sorry, it will be determined on the basis of transition function only. So let's take the transition function on Q1 first by placing two input symbol, that is A and B, and similarly we will find it out what will be the transition function behaves when I will put A and B on Q2. So let's take the first one, Q0, this is Q1, Q1 पे A दिया तो we will reach to Q1, okay. Next Q1 पे B दिया तो we will reach to Q2, correct? Okay, fine. Transition function Q2 पे A दिया तो we will reach at Q2, and transition function Q2 पे it is not A2, it is Q2. Q2 पे हमने B दिया तो we will reach to Q2 itself. Now in this example, how many states are there? That is, what is the status of Q? That is your Q1 and Q2, right? Q1 and Q2, correct? And what is your input symbol? Input symbol there are two input symbols, that is A and B, right? So how many possible combinations will be there? There will be your four combinations. Q1 on A is determined, okay, Q1. Q1 on B is determined Q2. Q2 on A is determined Q2, and Q2 on B is determining Q2. That means in every transition what we have got? We have got only one next state. That means there are two conditions here. First of all, we have taken all the combinations, that is done, first part. Second part, while determining the transition function, we are getting the next state at exactly 1. That means this is your DFA, this is your DFA, correct? So this is the second example I have given it to you. Now try to find it out whether this machine is DFA, in DFA or not. Please try it. Okay. How it will be resolve. Okay, first of all I will take all the transition functions. So transition function on Q naught. So what is Q naught? A, and transition function on Q naught on B. Okay, so on A I will get Q naught itself, and on B I am getting Q1. See, Q naught पे A देने पे we are residing on the same state, and while giving B I am reaching to Q1. Okay, next on Q1 by giving A I am reaching to Q2, right? It is not A2, it is Q2, right? And transition on Q1 by giving B on Q1, while giving B I am not able to reach any state, right? So please take this as account, right? Okay, fine. Next I will resolve this problem. Next is what? By giving transition on Q2 as A, I will reach to Q2 itself, and by giving Q2 B on Q2, I will again reach to Q2. Now observe the transition function. What observation we have made? That by giving all the transition function, we have taken all the possibilities. Yes, we have taken all the possibilities. Only one possibility has left, ये वाला. तो इसको हम लोग resolve करेंगे. Second is what? Second condition is what? कि whether the next state is more than one or not? No. Nowhere we are getting the output state or the next state more than one. So this is in your partial DFA, right? And one thing is left. That is Q1 on B is not defined here, है ना? Q1 on B is not defined here. Means I don't know कि अगर इसके ऊपर अगर हम लोग B अगर डालें तो ये कहाँ जाएगा? So that means अभी ये DFA में नहीं है. It is not in DFA. So how we will make it in DFA? Come to the third point. Third point is written here. If the state is not defined, अगर state अगर हमें अगर पता नहीं है, on a mapping, किसी एक mapping पे अगर हमें अगर state defined नहीं है, that means this state is not defined, then create that state as a dead state, right? Create the state as a dead state. That means what is going to be happen? इसको थोड़ा सा आप लोग please आप लोग इसको लिख लीजिए. Then I will make it DFA because it is your partial DFA, or it is right now it is not in DFA, right? So how I will make it as a DFA? That means, shall I remove this one? Okay, only this part I am removing. So what I will get? I will get by giving B, I will reach to a dead state. Dead state will be recognized as D, and again on dead state I will put A, comma B. That means how many total states are there? 1, 2, 3, 4, and on 4, all of the 4 states I have taken all the transition. I have not left any transition at all, right? So on transition on D also, dead state means D also. If I'll put A, again I will reach to the dead state only, and if I will put B, again I will remain on the dead state only. So this is the final example of DFA. Now it is a complete DFA. Earlier it was not a DFA because, why it was there? Because on Q1 B was not defined, right? So for defining the B on Q1, I have taken a new state, that is dead state, and on dead state also I have to put all the input symbols.